Now, welcome everyone. My name is Nessa Pawson. I'm a contributor experience lead for NumPy. I'm a Caucasian blonde woman wearing a navy blue dress and a blue headset. If you're just joining us, please introduce yourself in the chat. I'd like to remind you that all attendees of NumPy community events must adhere to the NumPy Code of Conduct. The NumPy Steering Council has made a strong commitment to creating an open, inclusive, and positive community. If you haven't done it already, please read the NumPy Code of Conduct for guidance on how to interact with others in a way that makes the community thrive. All attendees of our events must adhere to it. I wish for you all to have a positive experience at our events. If you see violations, take a screenshot, intervene in a respectful manner, and report to the Code of Conduct Committee via email. I will post this information in the chat as well. And now on to the main event. Deprecations are an important part of the software lifecycle. And today, Sebastian Berg, an NumPy core developer, will share his knowledge about deprecations in NumPy. Sebastian, please take it away.
Hi, everyone. I'm Sebastian. I'm currently working at the Berkeley Institute for Data Science on NumPy, and I've been a core contributor for a pretty long time in NumPy. Today, as Inessa said, deprecations are fairly important in our lifecycle because it's the only way for most things to move forward, to get rid of old features and then replace it with new ones and improve NumPy on the way. So it's an important part of moving forward. And one part of it is to introduce the deprecation, and the other part of the deprecation lifecycle is to then finally go through with it and finalize the deprecation. And today I wanted to show one, maybe two deprecations, just go through and finalize them. One in Python, and then maybe if you have time, we'll have a look at the C deprecation or start on it with it. So in generally, NumPy deprecations, we have a test file where some of them are listed. We also have on the issue tracker a small issue where some deprecations are gathered that tends to be a little bit outdated. So you have to go through a few to find one maybe, but you should be able to find some. They are also marked in the code always with when the deprecation happened, just to keep track of it. So if I can share screen now, let's see. Is this working?
Yeah, we can see.
Yeah. Okay, perfect. So let me maybe start with the issues here. We have an old issue which is marked as a tracking issue, as a task, sorry, about deprecations. Deprecate Python code with deprecation warning. And unfortunately, this is quite long, and a few of them have a note already about trickiness or what to follow up on. But one thing that is very old and that I want to look into today is the histogram with the norm keyword argument. So this was deprecated very, very long time ago, or at least intention to be deprecated in 1.6 already, which is before I started working on NumPy. So let's have a look at how to finally remove this norm keyword argument and replace it with the density one. So I don't know how familiar you are with histograms. We could check the documentation, I guess, just to, let's just Google it. NumPy histogram. So the NumPy histogram is a norm keyword argument, but the norm keyword argument is deprecated here. Let me make this a bit bigger. It's deprecated since NumPy 1.6, and it should be, the density argument should be used instead. So what we have to do is remove the norm keyword argument and replace it with the density, which already exists. How would I normally go about this type of thing? I have locally set up my environment here, and I personally use runtest.py usually, which runs our test suite and allows you to drop into an IPython shell. And if I open this, then NumPy is already imported. And I can check here histogram. So the main point, the first point is if I want to touch the code, I need to know where the code is. And I often use IPython for this because it's pretty quick. Just question mark, and then you see the code. If it was a C function, you would not see much, but in the Python functions, this works great, and histogram is written in Python. So here we can already see the signature, norm keyword argument here, and density over here. And if we scroll down, then we see also the warnings here. Yeah, deprecation warning. So all of this is if the norm keyword argument is active. So where does this file live? That we can see nicely. IPython tells us here it lives in NumPy lib histograms.py. So what we now have to do is modify the code, which there's usually something which makes it slightly more complicated. But let's have a look at the code first. So this is a NumPy lib. This is probably too small to see, but histograms. And then we should search for the histogram function. And there we go. And what I will do now, which I suppose we may have to discuss on the PR later also again, we have to get rid of the norm keyword argument. People might be passing the norm keyword argument by position, but normally the density is the same as the norm. So I will replace the norm keyword argument with the density, because passing both wouldn't make sense. So that should be fine. And one tricky thing about NumPy is that we have this array function dispatch. And if you look closely, there's a histogram dispatcher up here. So the normed equals num is here as well, it shows up here as well. So I have to do the same thing here. And for now, I will just keep this, make this change, scroll down since we can't be using normed anymore. Let me search for normed. So here, let's see what happens here. If density is not none, then if normed is also not none, then we give a deprecation warning. We don't need any of this. Norm does not exist anymore, so this branch can't be taken. Sorry, I pressed the wrong button. Okay, so this whole branch is unnecessary anymore. Now density is still ground. If normed is again never taken, so this warning can be removed. And this whole branch is also, this whole branch can also be removed. Normed is never true. The else branch can be taken, but normed can never be true. So this branch I can also delete. And in principle, the change is now already done. We can see here already below, if we look, NumPy doesn't have just histogram, but it also has histogram DD and histogram 2D. So those will also need changing. But let's, for now, do what we always have to do when we did a change. We run the NumPy test suite, which is the command python run test.py. I'm using 3.9 right now for reasons, but basically the Python you use will work. So the test suite will run a while for now. So I don't know why it takes so long, but in the meantime, I will just have a look at the documentation, because also that needs changing. Just delete this. Delete this. So this is histogram DD now, which I will have a look later. So what until now? Until now, I changed the signature, I deleted all the old code that is unnecessary now, modified the documentation, and I'm running the test suite right now.
Quick question.
Yeah.
For running the test suite, is there an option for like parallel dispatch there?
Yes, and I probably should have given that. You can do, so the run test doesn't have it, I think, or doesn't expose it right now. You can use xdist, the PyTest xdist.
So I have that. Can I just use the same like -n flag after the?
Yes.
Okay.
Yeah. So I can do it here too. I just, I don't know. I don't usually do it right now, but next run I will do it.
Gotcha. Thank you.
It should work. Yeah, pandas and a lot of projects use it. The NumPy test suite is a bit quicker than most, but it also takes 2 minutes or 3 minutes or so. So what we'll have to do after this test is now fix all the tests that break. Think about if we have to add new tests. I think in this case, we don't really have to add any new tests probably because it's just a removal. But normally you probably have to add some new test to replace whatever tests was there. Okay, we got lucky. There's only a single test failure right now, and it's in test histogram test normed. I already got it here. Test normed. So the test normed one is basically testing the deprecation warning if normed was passed. It's a bit surprising. There should probably be more tests here because I don't think these exercise all the code passed where we give warnings, but so be it. We don't actually need to worry about that right now. I will replace this test with a test that just briefly checks that indeed normed raises an error. So it basically calls histogram here. The result won't work anymore, so this will be an error. So I will say b equals np.random. Let's just take 10 or 100, and then with pytest.raises. This should raise a type error because type errors are raised if there are any missing keyword or additional keyword arguments. Okay, so this should replace the old test with the new one that just checks that there's an error and should probably work. Hopefully I didn't do a mistake here. We can just run this one test so that it's a bit quicker. I won't run that in parallel. Why doesn't
that's not removed.
Oh, yeah. I renamed it, right? Exactly. Thanks. So that doesn't exist. Okay, so I changed this test now. The test should fully pass now. So we have to continue with all the rest around this, which is the non-keyword argument wasn't just in histogram, but it was also in all the other histogram functions, unfortunately. So we have to do the same thing for histogram DD. Again, move the density keyword argument. The dispatcher, which is a bit special in NumPy that we have this. And then let's see. Okay, I can just change this. Let's see what we have to change. Let's change that actually. Density is true. probably. In the review process, we might have to check this a bit more carefully. Normed shows up only down here. This is normed is none. This is all just normed and density. Argument to make density normed if true. Then we have the density, which we keep. So this is actually seems to be already it. If I search for normed, there's no other result. So this changes histogram DD. Let's run the test suite with this. So the way I can run the test suite right now with the xdist, I think it's installed, is minus n6. Let's see. No. How does it work with xdist?
I think usually lowercase n and then.
Lowercase n. Thanks. Not good. Yeah, this is it. So the run test doesn't forward it right now. So I'm using the dash to pass arbitrary arguments to PyTest. That's how run test is set up. You can also run PyTest directly, but this is kind of convenient. I'm wondering if I'm using an old version of PyTest because it's running fairly slow, and I thought PyTest improved the speed here, but
So for the run tests, it what does it rebuild NumPy each time it launches the test suite?
yeah, it rebuilds NumPy, but since it only recompiles if there are actual changes, and then I have Ccache installed, so rebuilding is normally so quick that I don't care about it.
Well, what did you mean? Ccache? What is that?
I don't know how much influence it has, honestly. Ccache is a program that wraps GCC or wraps the compiler and only recompiles files that actually changed. So even if but I'm not sure if that matters, whether it's the Python setup installer that avoids recompiling or whether it's the Ccache that kicks in and improves the speed. I'm not quite sure what's the important component.
Okay, I guess it's probably going to be the Python thing, because same thing in scikit-learn, it can avoid the redundant recompiles.
Right, it should avoid it. I suppose Ccache might help if you do git cleanup and then all of it is gone. Then the Ccache might kick in and still replace some of it. Okay, so we have a couple of errors here, and most of them seem to be, there's some here, all of them is this histogram dispatcher, which is a bit annoying in NumPy that it gives the histogram dispatcher here. But all of these are that we give too many keyword arguments somewhere or something like that anyway. The test histogram 2D kind of makes sense. We never touched any histogram 2D function, so we have to check that out. But let me start looking at the first error maybe. So, okay, this is already histogram 2D. So what I should do is I should check out histogram 2D and see what's going on there. And since I'm not sure, it's not in the same file, I think, because I searched for normed. I will do this again. Okay, so histogram 2D also uses the norm keyword argument and the density keyword argument. And it does so by calling histogram DD internally. And the way it is defined in 2dim base, so it's not defined in the same file. 2dim base, histogram 2D. Oops. Okay, so we need to do the same change here. Norm becomes density. There's the dispatcher. So we do the same thing here. Norm becomes density. Then we should delete all the norm stuff here. The resulting is the sample density. Yeah, that is okay. I can just replace that. Okay, and here we pass density by position rather than the normed. I suppose we could also pass by keyword nowadays. Python used to be a bit slower with keyword arguments, but I think it's now so quick that it shouldn't matter much. So this fixes the 2dim base. I will run the test suite for now to see if that actually fixed all or most of the errors. Let me check while we're waiting. There's no more normed here. No more normed here. Good. At some point, I should also check the general documentation, but I think I will defer that and see after we have a PR and then check again then. Any more questions while we're waiting for the test to run? Should it probably just run the specific test that failed? That way it wouldn't take this long. The problem is that gathering the finding all the test itself is already pretty slow right now. Okay, there we go. Okay, down to 2 failures. That's good. Density via normed, that should fail. Density normed redundancy also should fail. This is also in test histogram. .py, but we already edited that. So let's see. Normed should simply alias a density argument. You know what? I will also do this. I don't know if it's worthwhile, but let's do this. Where's that? Let's just see that it fails. Cannot specify both. That really is completely unnecessary as a test. So we can delete that. Let's check that I got it right. So this is, I just deleted the function here, telling PyTest to run only the histogram DD tests. And all of them pass. So this is good. I could check the whole diff now, but should probably have done that before time. Let's make a branch.
I have another question whenever you.
Yep.
So the tests that you just added, the removed tests, right? Sorry if you mentioned this earlier, but would that kind of test have to go through its own deprecation cycle at this point? Because I imagine at some point you wouldn't necessarily need that there.
What do you mean with going through its own deprecation cycle?
Well, basically, like at some point in the code base, would you want to remove this test, just like eventually when normed is just not even?
Yeah, I mean, honestly, I'm not even sure that it's useful right now. I mean, yeah, you're right. It's not, the norm keyword argument obviously doesn't exist. So
Yeah, he has a point. I think technically this could even be removed.
maybe we should just remove the test, honestly. I mean, I could make a comment that it could be removed, but let's just remove the tests. It's nice, I suppose, to check once just for yourself that you know that it's been removed.
Right, the sanity check.
Hmm?
The sanity check.
Yeah, the sanity check is always good, but really, it doesn't really make sense. It's not like we test every possible keyword argument that doesn't exist. Okay, so I think I just created a branch. Way too many branches, yeah. We have this commit messages. We usually do like deprecations with dep. It's not a big thing, but so the one thing that in theory, the density behaves a tiny bit different than the norm keyword argument, but I think I will just ignore that for now because it's just too obscure to worry about too much. Because if someone would pass the norm by position and then miss the deprecation warning, then now they would get the correct behavior suddenly instead of the old bad behavior. So I think arguably we can glance that over. Okay, so I committed and push this and open the pull request. Oh no. Okay, let's just edit it here for now. So I have now done all the code changes, hopefully. The tests here should run, hopefully pass online. I mean, there's always some chance that something didn't show up locally because I only didn't run the full test suite or something. So it's always possible that there's some complaint here, or I might just have linting test might fail and warrant a small look if I should change some code style. But one thing that is still missing and that is part of any deprecation is that deprecations should have a release note. So someone might come along and even put this tag on it, needs release note. So let's write a very brief release note for this. Release notes in NumPy are currently, the way we do it is we use town crier, and they live in doc release upcoming changes. And there is a small README here that explains how to write a release note. Maybe I should open it here. Doc release README. So it's a bit long, but basically we have different type of sections in the release notes, and we have to pick one of these. So in this case, that is an expired remove of a deprecated part of the API. So it's expired. And then usually for expired ones, we use the bullet, just a bullet point. And that's it. So the reason why I opened the PR first and then write the release note now is that you actually need the pull request ID to create the release note. So it's the other way around, doesn't really work. So what we do is we create, look up the pull request number up here. Dot expired dot rst. And then just a bullet point is probably good enough. And p.histogram. Histogram 2D and DD. That's right. Use density instead. So the subtlety here is different. It's the different behavior for what's it called? So if the bins are different sized, if the bins don't have all the same size, then it behaves differently, if I remember right. So let's just keep it for now. So just a brief release note saying that the nom keyword arg is removed from all the functions where it previously was, and that density should be used instead. Let's add that. And push. Okay, and basically we now have a pull request that is probably good to go. There might still be some discussion or something that I missed that the reviewer might find. Usually there is some follow-up just because you forget something or because the reviewer is worried about just removing the norm or replacing the norm with density with the broken. So this is the broken behavior. But I think in general, this is probably all that is needed in this case. There's always a chance that more tests. So in this case, there were very few tests that failed, very few new tests that we had to add, which is none. But this is the typical process to do removal. Do you have any questions about this? And I suppose since it's pretty late, we should probably just cut it and not go too much further. I was thinking about showing some C code deprecations. I could have briefly show how the deprecation looks in C code. Not maybe go through with it, but just show how the deprecations in C code look like and how the code changes there would look like.
Well, perhaps we could open up a floor for questions so far. And then if we don't have many, we could move to the next topic.
Sounds good. I hope I wasn't way too quick, but.
To update the issue tracker, right, for the deprecations.
We have a tracking issue. It's 11521. It has its task and deprecation labels if you want to search for it. There are a couple of deprecations here that are outdated or just probably need a bit of thought. So if you run over, you look at some and get stuck and are not sure, just post a comment, because I think unfortunately fairly often in NumPy there are tricky situations where it's a bit tricky to know exactly how to proceed. And the best thing is just to ask and see if one of us knows. Like I had looked at this one before and this one was half done. And then I realized that in insert, there's still a future warning. but actually I'm not sure how the future behavior should look like on first sight. So I skipped that one for today.
Any more questions for Sebastian? And just keep in mind, you are welcome to post your questions in the HackMD document that I shared or directly in the chat. And I'll just copy it in the document. We're trying to keep track of the questions as well, so maybe we could enhance our documentation if needed. It sounds like no questions for Sebastian. We have about 15 more minutes. Do you think you have enough time, Sebastian, to work on the C code deprecation?
What I will do is not work through all of it, I think, but just show how it looks like typically in C code. In this issue, we also have a few C-deprecations. Okay, maybe I'll just pick one at random because I'm not like I had picked one out, but it's not actually listed here. So, oh wait, let me go back to that. So one thing that the histogram deprecation did not have, that a lot of, especially the C ones actually do have, is that in NumPy core test deprecations, we have a huge amount of deprecations in this file that is half for historical reasons and half because if you do a deprecation in C, it can be either warnings or they can be raised as an error. So you have to check both the error path and the warning path to make sure that both work fine. So in that case, this deprecation test case is kind of useful. That's half the reason why we have this file. And okay, I will just pick one on random. Unfortunately, let me pick one with the nice invalidate. I have no idea what this does, so it's perfect. Invalid data. So this apparently deprecates from file or from string, and they give a deprecation warning when the file is too short or something like that. And oops, I closed my terminal. Okay. So the way I would go about here now is not necessarily try to know where things are, but I just use git grep. Git grep is just git and search for the error message, because more often than not that works. It doesn't always work if the error message is broken or something. Okay, so this is in multi-array ctours.c. We could have also searched for from file and went through from there. So it was in source multi-array ctours.c. And then let's search for it, deprecated. So this is how most deprecations in C look like. We have a deprecation macro, deprecate macro that we use, and just the text. If it returns smaller null than zero, smaller zero, then an error was raised, and we have to do a normal error handling, which is a go to fail in many cases at least, or return null. And otherwise a warning was raised and things just continue normally. So what we would do is, in this case, we would replace this deprecate with the value error. It actually says here, right? This will be a value error. So either an error is already raised, or you can just start for now. Set string. So if you are familiar with the Python C API, this makes sense to you. If not, then this might be very confusing. But basically, this is the way you raise or set an error, which is the same as the raise keyword argument in in Python itself. We raise a type error, this PyX type error, and then we can actually just steal this probably. Oops. Stringify could not be read to its end due to unmatched data. And then this is an error, so you also have to do error handling here. We don't need an if, sorry. So this is a Python error. This is an error, so we always have to go to the error path. Previously, it was a deprecation. A deprecation can either raise a warning and continue normally, or raise an error, and then you have this if and both branches. Now we just have a go to fail, which we don't even need. Oh, there's a Py error occurred here. Well, okay, this works. I feel this could probably be cleaned up a little bit down here, but that doesn't matter much. So this should actually already work. And if we want to, we could run the test suite. Now it would have to recompile, right? But it's pretty quick to compile. If it's just one file, if it's some header files deep down, then it can take a long time to recompile. If it's just one file, it's very quick. So in this case, we will definitely have to modify the test deprecations because all of this is now not useful anymore, and replace that with actual errors, because in this case, the error is an interesting error and not a missing keyword argument where we don't have to create a new test file. But maybe since we have only 10 minutes left and maybe want to chat a bit, we should just cut at this point. The rest of the process, I think, it would hopefully, if I got everything right here, and aside from thinking if we can improve the error message, would just be the same as we did in the histogram code, and it would also be just on mostly Python code, hopefully only Python code for this time. So maybe I stop sharing my screen, unless there are some questions about the C API, about other things. The C API can be pretty overwhelming, and then things like reference counting, getting that right is tricky, but reviewers will help out if you get stuck with that. It's not a problem. You can just open a PR and see what we say and find. Good. Thanks, everyone.
Sebastian, thank you. Thank you so much for spending your valuable time with us and showing the ropes. I will stop the recording now and I will open up the floor for questions.